Quantitative analysts are currently stress testing multimodal large language models to see if they can consistently forecast financial markets. A recent study put GPT-4o to the test, evaluating its ability to predict end-of-month stock price movements for 16 major companies listed on the KOSPI 200. The results revealed an extreme disparity in the model's capabilities. For a stock like Lotte Energy Materials, GPT-4o achieved a flawless 100% predictive accuracy. Yet, running the exact same architecture over the exact same timeframe, the model yielded a 0% accuracy rate for Korean Air. General-purpose LLMs are not uniform financial oracles. Their predictive power is highly volatile, bound entirely by specific identifiable constraints within the data they ingest. The experiment ran from January to May 2024. At the end of each month, the model was tasked with predicting the closing price direction for the targeted stocks. To make these predictions, the LLM was fed a multimodal diet consisting of financial statements, recent news articles, and raw stock charts. The researchers applied a zero-shot chain-of-thought prompting strategy. This method forces the model into a state of self-evaluation. It requires the LLM to explicitly justify its financial intuition step by step before it is allowed to output a final prediction. Because the prompting architecture remained constant across all tests, any variance in accuracy must stem from the underlying nature of the companies themselves, specifically their industry sector and market capitalization. To understand this variance, we first look at direction accuracy. This simply measures whether the model correctly predicted if a stock would go up, go down, or see no change. This table breaks down the model's success rate by sector. Notice the high efficacy in the technology and healthcare sectors. Lotte Energy Materials sits at 100%, while Samsung Electronics and Celltrion achieved 80% accuracy. Contrast those strong performances with the complete collapse of the model's predictive capabilities in other areas of the market. Finance, industrials, and telecom emerge as the primary lagging sectors. The model struggled severely here, scoring just 20% for IBK and KT and a flat 0% for Korean Air. General multimodal inputs clearly failed to capture the highly specific macroeconomic forces, regulatory shifts, or opaque operational variables that govern these lagging industries. The researchers then evaluated the data along a second axis, market capitalization. Here, the target companies are resorted into 3 tiers based on size: top, middle, and bottom. Comparing directional accuracy reveals a distinct baseline advantage for large-cap entities. The top tier averages 60% accuracy, outpacing the middle at 47% and the bottom at 48%. This aligns with a logical hypothesis. Large-cap companies inherently produce a denser, higher-quality public data footprint. More consistent financial reporting and heavier news coverage act as better fuel for the LLM. But size does not guarantee success. Look at LG Chem. Despite its massive market cap placing it in the top tier, its prediction accuracy was an abysmal 20%. While market capitalization establishes a baseline of data quality, industry-specific volatility and complexity can completely override that advantage. Directional accuracy has a serious limitation. Predicting an up movement is functionally useless if the model expects a 20% rally, but the actual move is only 1%. To solve this, the researchers introduced the bin score. This metric rigorously quantifies both the magnitude and proximity of the LLM's prediction against the actual price variance. The grading system works on intervals. If the predicted price magnitude lands exactly in the same interval as the actual price move, it scores a perfect 5. The score drops step by step for every interval the prediction misses by, down to 0. Applying this metric tests the large cap advantage. The top 5 cohort maintains a dominant lead with a 2.4 trimmed bin score, well above the lower tier's 1.8. Within this group, Celltrion achieved a massive 3.4, and Samsung Electronics a 2.8. These high bin scores prove the model was not simply coin-flipping directions. In data-rich sectors, the LLM was accurately sizing the exact magnitude of complex market moves. The KOSPI 200 data points to one ultimate conclusion. An LLM's predictive engine is entirely bottlenecked by its information diet. Large-cap tech and healthcare succeed because they generate massive, consistent financial reporting and dense, unambiguous news coverage. That volume of high-quality data gives the model the context it needs to reason effectively. Conversely, for mid-cap companies or those in opaque sectors, public data is often fragmented and of lower quality. Without a solid informational foundation, the model's reasoning chain collapses. For algorithmic traders and researchers, the takeaway is direct. General zero-shot prompting is insufficient for market-wide deployment. To successfully forecast those lagging sectors, developers must build bespoke, sector-optimized data ingestion pipelines and specialized prompt architectures tailored to the nuances of each industry. The future of AI in quantitative finance does not lie in possessing the biggest generalized model, but in constructing the most highly curated, sector-specific data architecture.